So this is 5.8, shopping for cats and dogs, and this is a develop understanding task. Clarita is upset with Carlos because he has been buying cat and dog food without recording the price of each type of food in their accounting records. Instead, Carlos has just recorded the total price of each purchase, even though the total cost includes more than one type of food. Carlos is now trying to figure out the price of each type of food by reviewing some recent purchases. See if you can help him figure out the cost of particular items for each purchase, and be prepared to explain your reasoning to Carlos. Alright, well, what we're going to do then is we're going to read some problems and try to translate the problem into a system of equations that we can solve. Alright, so here's the first situation right here. 1 week Carlos bought 3 bags of Tabitha tidbits. Alright, how would we write 3 bags of Tabitha tidbits algebraically? Let's think about that. Could we just call that a 3t, where t is the number of bags of Tabitha tidbits? And 4 bags of Figaro flakes, and could we write that 4f, where f is the number of bags of Figaro flakes, and that cost Carlos $43. The next week he bought 3 bags of Tabitha tidbits, let's go 3t again, and 6 bags of Figaro flakes, let's call that 6f, and that cost Carlos $54. Based on this information, figure out the price of 1 bag of each type of cat food. Explain your reasoning. Alright, so we have 2 linear equations here in standard form. Alright, and this creates a system of equations where we know the solution to the system would be the point where if we graphed each of these linear equations, it'd be the point where they intersect. Now, if we don't have graph paper and rulers, it's hard to do that perfectly, so we need to find another method here. And there is a great method for solving systems called elimination. And what we do with elimination is we look at the 2 equations and see if we can add or subtract them to cancel one of the variables. Now look over here on the left. I have 3 t's here and I have 3 t's right here. So if we subtracted the lower equation from the upper equation, our t's would cancel out. And then we could solve for the f. Let's give this a try. Alright, so what I do is I put my minus out front and then a line right here and make sure we're subtracting each term from the term above. Alright, so 3t minus 3t cancels, and then I go to my f's, Figaro flakes. 4f minus the 6f, so that's going to be a negative 2f, or negative 2 bags of Figaro flakes. And then 43, and don't forget we're subtracting minus 54, that would be negative 11. Now we have an equation in 1 variable and we can solve for f, the number of bags of Figaro flakes. And how do we undo multiplication? We divide. Let's divide both sides by that negative 2. Equals, alright, now think about this a second. The factors of negative 2 cancel on the left, leaving our factor of f, and f equals negative 11 divided by negative 2. Alright, so what's a negative over a negative? It's positive, and how many times does 2 go into 11? That would be 5.5. So this statement right here implies Figaro flakes cost, again, negative 11 divided by negative 2 is 5.5, or in dollars and cents, $5.50 per bag. Now, we can take this value for f and plug it into any of the original equations to solve for t. Alright, so let's put this f as 5.5 right there, direct substitution, and then solve for the t. So we have 3t plus 4 times f, which is 5.5, equals 43. Let's clean this up. So that would be 3t plus, and 4 times 5.5, well, 4 times 5 is 20. 4 times 0.5 would be 2, so 20 plus 2 would be a 22 equals 43. And now we have a two-step equation that we can solve for t. Let's undo this plus 22 by subtracting 22 from both sides. Bring down the equals, and we're left with 3t on the left equals 43 minus 22. That would be negative, or positive 21, excuse me. And now you divide both sides by the 3. Okay? So let's think about this a second. Do you agree that those factors of 3 cancel? So t is 21 divided by 3? That implies Tabitha Tidbit's cost, well, 21 divided by 3 is 7, so that's $7 per bag. All right? So if I remember right, didn't they say the Figaro Flakes was the more expensive cereal earlier? They must have changed things up. Interesting. All right, and that's how we can help Carlos out to convince Clarita of the cost of each type of dog food or cat food. We've got this. Okay, number 2. One week, Carlos bought 2 bags of Brutus Bites. Do you think we might write that as 2B? Plus 3 bags of Lucky Licks. And that cost him $42.50. The next week he bought 5 bags of Brutus Bites, how about 5B, plus 6 bags of Lucky Licks, 6L, and that costs $94.25. All right, now this is a system of equations, but I can't simply add or subtract and cancel one of the variables here. So I wonder if we could manipulate one of the equations, so we could. Let's see. Well, doesn't 3 go into 6 2 times? So could we take the top equation and multiply everything by -2? All right. Now watch. Let's rewrite and see what happens. Well, -2 times 2b, that would be -4b. And then -2 times the 3L would be -6L. And then -2 times the $42.50 would be negative, what would that be? -$85? -$85. And now I'm going to ignore that top equation, at least momentarily, and now focus on this system. Because now in this system, do you see the 6L up top and the -6L down below? If I add these two equations, my L's will cancel out. So let's add them. Okay, so 5b plus -4b would give me a b. And the 6L plus -6L would be 0. And over here on the right, $94.25 plus -$85, that means I'm subtracting the $85, would be what? $9.25. So Brutus Bites are costing $9.25 per bag. Okay, now we can take that 9.25 and substitute it into either of our original equations to solve for the L. So, I don't know, there's 2 B's right there. I probably put it right there. Let's see if I did. 2 times B, which is $9.25, plus 3 times L equals $42.50. All right, no, I'm ignoring the -2 out here. I'm just using my original equation. Now let's clean this up. So the 3L equals $42.50. We'll leave that alone. But what is 2 times 9.25? That'd be 18.5 or $18.50. All right. Now let's solve this two-step equation for the L. So let's subtract 18.50 from both sides. And that's going to give me the 3 L's equals 42.50 minus 18.50. All right. Well, I'm a little tired, so I'm just going to punch that one out. 42.5 minus 18.5, and I'm getting $24. Well, that's nice and clean, because now look, aren't we going to divide both sides by this 3 to undo the multiplication? All right. So Lucky Licks would cost, well, the 3's now cancel, so Lucky Licks equals 24 divided by 3, and 3 goes into 24 8 times. That's $8 per bag. Alright, this is going pretty darn well. Yeah, I'm excited too. Number 3, Carlos purchased 6 dog leashes. Now, do you notice previously we've been using B's and L's and T's and F's? Boy, we're getting a lot of different variables here. Let's clean things up a little bit. Can I do this? 6 dog leashes. How about we'll let X imply anything that has to do with dogs, and Y anything that has to do with cats. So I'm going to write 6 dog leashes as 6X plus 6 cat brushes. How about 6Y? For $45 equals 45. Oh, that's easy. For Clarita to use while pampering the pets. Later in the summer, he purchased 3 additional dog leashes, 3X, and 2 cat brushes plus 2Y for $19 equals 19. All right. Now, I look at these 2 equations in the system of equations, and again, I cannot add or subtract right now and cancel one of the variables, but I do have a lot of options of what I could manipulate to clean things up here. Can I take this bottom equation and multiply everything by 2? Because watch what happens. All right, 2 times 3x is 6x, note the 6x above, and 2 times 2y would be 4y, and then 2 times the 19 on the other side would be 38. Now, let's cross out that equation momentarily, and you see the 6x over the 6x, we're going to subtract. Alright, so 6x minus 6x cancels, and then I have 6y minus the positive 4y, that's a 2y, and the $45 minus the $38, and that would be $7. So if 2 times y is $7, wouldn't y have to be $3.50? Divide both sides by 2, and cat brushes cost, the 2's cancel right there, and y is $7 divided by 2, or $3.50. Now, dog leashes. How about we substitute into our original equation right there in the middle? 3 times x plus 2 times y, and we just said y was $3.50, or 3.5 if you like, equals 19. Now, let's clean this one up. So we have the 3 x's, and then 2 times $3.50 would be $7 equals $19. Let's subtract $7 from both sides. Equals, and then 3x on the left, and 19 minus 7 would be 12 on the right. So if 3 times x equals $12, wouldn't x have to be $4? Well, let's show that. So we're going to divide both sides by 3. Implies dog leashes will cost, and the 3's cancel. So x, the number of dog leashes, is $12 divided by 3 would be $4. Okay. Wow, now what happened? One week, Carlos bought 2 packages of dog bones. How about if we call that a 2x? And 4 packages of cat treats. For why? For $18.50. So 2x plus 4y equals $18.50. Because the finicky cats didn't like the cat treats, the next week Carlos returned 3 unopened packages of cat treats. So returning 3 packages of cat treats, if y is the number of cat treats, packages of, could I write that as a negative 3y? Alright. And bought 2 more packages of dog bones. Another 2x right there. And how much did that cost them? After being refunded for the cat treats, Carlos only had to pay $1 for his purchase. Okay? Based on this information, figure out the price of each item. Explain your reasoning. I like this one. We see the 2x right here and the 2x right there. How about if we just subtract those 2 equations? So our 2x's cancel. Equals, And now I have 4y, now be careful here, minus negative 3y. Well, 4y minus negative 3y would be 4y plus 3y, or 7y. And $18.50 minus $1 would be $17.50. Excuse me. Now, let's divide both sides by 7. Okay, so cat treats costs. Let's cancel the factors of 7 on the left. And I'm going to get out my calculator and go 17.5 divided by 7. And I'm getting 2.5, or $2.50. Nice. Now let's substitute that y into one of the original equations. Okay, we're going to go right here. And remember, this is not a negative for the 2x. This equation was 2x minus 3y equals 1. So 2x minus 3y, which is now $2.50, equals $1. So 2x minus, well, 3 times 2 would be 6, and 3 times 0.5 would be 1.5. So what would that be, $7.50? And if you're not sure, check it on your calculator. Now, we have to undo this subtraction of 7.5 by adding 7.5 to both sides, equals, and on the left I have the 2 x's, and on the right I have $1 plus $7.50, that'd be $8.50. So 2 times what x value is $8.50. Sounds like $4.25 to me. Let's divide both sides by 2 and double check that. So dog bones cost, cancel your factors of 2, and x is $8.50 divided by 2, which should be $4.25. I think we're getting the hang of this. Now, Carlos has noticed that because each of his purchases have been somewhat similar, it has been easy to figure out the cost of each item. However, his last set of receipts has him puzzled. Uh-oh. One week he tried out cheaper brands of cat and dog food. On Monday he purchased 3 small bags of cat food, so that would be a 3y, and 5 small bags of dog food, 5x, for $22.75, equals $22.75. Because he went through the small bags quite quickly, he had to return to the store on Thursday to buy 2 more small bags of cat food, that would be a 2y, and 3 more small bags of dog food, 3x, which costs him $14.25. Okay. Wow. Okay, I cannot add or subtract right now. And because 3 does not go into 5 and 2 does not go into 3 evenly, I can't manipulate just one of these equations. It looks like I am going to have to multiply both equations by a number to find something that will cancel. What do you think? Alright, what if we take the top equation and multiply by 2 to get 6y's, and then we take the bottom equation and we multiply by 3 to also get 6y's. Oh, look at that. Now we need to rewrite both of them. So 2 times 5x, 10x's. 2 times 3y's, 6y's. And 2 times $22.75, let's do this carefully, that'd be 44, 44.75, 45.50, $45.50. And again, you could just punch that out. All right. And then the bottom equation, 3 times 3x would be 9x. 3 times 2y would be 6y. And 3 times $14.25, well, let's try it without a calculator. 3 times 10 is 30. 3 times 4 is 12, so that's 42. And 3 times 25 cents is 75 cents. Is that $42.75? That's kind of a cool way to do that. And again, you could just go 3 times 14.25 on your calculator. Now look at our 2 equations. 6y's over 6y's, I think we can subtract. And now look how easy this becomes. 10x's minus 9x's would be x. 6y minus 6y cancels, And $45.50 minus $42.75, is that what, $2.75? $2.75. So guess what? And X was what? Small bags of dog food. So that implies small bags of dog food cost $2.75. Now let's substitute that 2.75 into one of the original equations for X to solve for the Y. How about this one right here? And remember, let's not use that 3 on the outside anymore. Keep it easy. So 3 times our X plus 2 times our Y is 14.25. And our Y, or our X, is 2.75, or $2.75. For some of you, the arithmetic is easier when you think of it as money too, by the way. All right, so what is 3 times 2? Well, the other part's going to stay the same, so I'll leave that alone. Now, 3 times 2 is 6, and 3 times 75 cents would be what, $1.50, $2.25? I think that's $8.25. Yeah. Now let's solve for that Y. So let's subtract the $8.25 from both sides, equals, and $8.25 minus $8.25 gone. And I'm left with 2 times the number of small bags of cat food, 2Y, is $14.25 minus $8.25. That'd be $6. So if 2 times Y is $6, isn't Y $3? Let's divide and check. Implies small bags of cat food cost, cancel those 2's, and Y is $6 divided by 2, which would be $3. Nice. All right. Clarita, okay, that first paragraph is our original paragraph, so let's jump right down here. Summarize the strategies you have used to reason about the price of individual items in the problems given above. What are some key ideas that seem helpful? Well, first of all, if we can add or subtract our 2 equations and cancel a variable, that's what we did most often. All right, but more often than not, we had to manipulate before we could do that first. So I'm going to start with a number 1. Manipulate one or both equations so you can add or subtract the equations and one of the variables cancels. And then you solve for the other variable, solve for the remaining variable, and now you have a value for your second variable. Can't we substitute that value into one of the original equations to find the other variable? So 3, substitute that value into one of the original equations to solve for the second variable. That's it in a nutshell. Okay, now you guys get the Ready, Set, Go for 5.8 complete, and get a hold of me if you need a little extra help. You guys have a great day.